Let's look at some examples. So here I am looking for the scale factor. And scale factor is a first degree measurement. So scale factor. So if I have the volumes, which is a third degree measurement, so volumes is a third degree measurement of 225, I'm going to go ahead and reduce that. 25 goes into 208 times with 1 in the denominator. Now I want to bring that down to a first degree measurement. So in order to do that, in order to take that to a first degree measurement, I have to take the cubed root of both of those because I'm going from a third degree measurement to a first degree measurement. So I'm going to take the cubed root of 8 and the cubed root of 1, and that's going to give me a ratio of 2/1, or a scale factor of 2/1. So that is how I get that measurement down. The next one starts with surface areas, which are second degree measurements. And I have 45/20. And I'm going to go ahead and reduce that as well. 45/20 reduces to 9/4. And again, I want to get that down to a first degree measurement. So because I'm going from a second degree measurement to a first degree measurement, I'm going to take the square root of both of these. And that's going to get me 3/2. Okay. In this next example, I'm looking at two rectangles that they have off to the right. And I actually have side lengths. So those are first degree measurements. So I can write a scale factor of those of 6/9, but I always want to reduce. So I get 2/3. Okay. Now if I asked you the ratio of the areas, I'd have to take that 2/3, which is a first degree ratio, and I have to convert it to a second degree ratio by squaring both of these pieces. So I get 4/9. Okay. Now, they give me the area of the smaller triangle, but not the larger triangle. But I can use this ratio, 4/9, to find the area of the larger rectangle. So what I have here, I know I have the smaller one. 4 is a smaller number, so 72 has to be placed with that. And now I'm just going to cross multiply. So I have a proportion, 4x is equal to 72 times 9. And I'll multiply that out. (72 times 9 is 648. 4x is equal to 648, and then I'll divide by 4 on both sides, and I get x is equal to 162. So the height of the larger rectangle, the area of the larger rectangle is 162 inches squared. I'm not quite sure why I said height there. I apologize. Okay. So in number 3, they give me the ratios, or they want me to find the ratio of the volumes. And they're giving me different information. So the first one starts by giving me side lengths, which are a first degree measurement, 4/5. Great. So now to get that into a third degree measurement, I just have to cube these. So I get 64/125. So all I did was cube each of those numbers. Now number 5 is a little bit more complicated. I'm actually going to draw a chart for this. So 1, 2, and 3, and I'm going to talk about what each of those means. So each of those numbers represents the degree I'm looking at. And I am starting with a second degree ratio. So I have 64 over 49. And ultimately, I want to get it to I want the volume of the ratio of the volumes, which is a third degree ratio. But I have no way of going from a second degree ratio to a third degree ratio. So what I have to do first is bring this second degree ratio down to a first degree ratio. So I'm going to take the square root of 64 and the square root of 49, and I'm going to get 8 over 7. And now I can take that piece and I can bring it up and cube both of those. So I can do 8 cubed over 7 cubed. So I have to go down to a first degree ratio, and then I can bring it up to a third degree ratio. So I get 512 over 343. And that is the ratio of the volumes of those figures. Okay. In this next one, they tell me a small spherical hamster ball has a diameter of 8 inches and a volume of about 268 inches. A larger ball has a diameter of 14 inches. So I have two diameters. I can write a ratio between them, and that's going to be a first degree ratio because I'm looking at diameter. I always like to reduce, so I'm going to reduce that to 4 over 7. But now I'm looking at finding volumes. So what I'm going to go ahead and do is turn this into a third degree ratio. I'm going to cube each of these. So I'm going to get 64 over 343. And then I can say that that is equal to 268 over x. And you may be asking, how did you know that 268 was in the numerator there and not the denominator? And I knew that because the numerator of this ratio is the 8. And they told me that the hamster ball that had a diameter of 8 had a volume of 268. So those have to go together. So now I'm going to proceed by cross multiplying. And I'll divide by 64 on both sides. And I get approximately 1,436.3 inches cubed. Okay, now they're telling me that I have a surface area. Surface area is a second degree measurement. So I'm starting with 64 over 144. Okay, and I can actually reduce that quite a bit. Okay, so I can reduce that all the way down to 4 over 9, because 144 divided by 16 is 9, and 64 divided by 16 is 4. Okay? So that is the ratio of the volumes. That's the ratio of the surface areas, but I'm looking for the ratio of the volumes. So I'm going to start with my 1, 2, 3 chart, and I'm going to put this ratio exactly where it belongs in the 2 part of it. And then I'm going to bring it down to a first degree ratio. So I'm going to take the square root of 4 over the square root of 9. That gets me 2 over 3. And since I want to find a volume, which is a third degree ratio, I'm going to bring that back up and get 2 cubed over 3 cubed, which would give me 8 over 27. So now I can say 8 over 27 is equal to, and look, the volume of the larger cylinder is 216 meters cubed. So I know that that 216 has to go with the larger of these two numbers, which is 27. So I'm going to put an x in the numerator and the 216 in the denominator, and then I'm going to cross multiply. 27x is equal to 8 times 216. That gets me 1728. And I'll divide by 27 on both sides, and we get x is equal to 64. So we can say that the volume of the smaller cylinder is 64 meters cubed. All right. So now they're telling me the volumes of two prisms. I don't even know what shape they are. I just know that they're prisms are 135 and 5,000. The volumes. So that is a third degree ratio. So I'm going to go ahead and set that up. I always like to reduce. So let's go ahead and do that. And when I do that, I get 27 over 1,000. And if they want the ratio of their heights, I need to take that down to a first degree measurement. So I get 3 over 10 in the first degree. Okay. Now to find the ratio of their areas, or the area of their bases, that's a second degree measurement. So what I'm going to do is I'm going to take the first degree measurement I just found, 3 over 10, and I'm going to square both of those to bring it up to a second degree measurement. So I get 9 over 100 as my answer there. All right. It says cone A has a diameter of 10 inches and cone B has a diameter of 50 inches. If the cones are similar, find the volume ratio of cone A to cone B. So I'm going to start with that. I'm talking about diameters, first degree ratio. I'm going to reduce it to 1 over 5. And then in order to find the ratio of the volumes, I'm going to cube each of these. So I get 1 over 125 as the ratio of the volumes. Okay. It says how many times larger is the volume of a cylinder if the radius is multiplied by 6? So what we have to keep in mind here is that we were given a first degree measurement. So first degree measurement is radius. That is 6. I am multiplying it by 6. But I'm talking about, I want to know how many times larger the volume will be. And the volume is a third degree measurement. So I'm going to take that first degree increase and I'm going to cube it, which is going to get me 216, and the volume will be 216 times larger, okay? If I look at this next one, it says how many times larger is the volume of a rectangular prism if each measurement is tripled? Well, each measurement meaning length, width, and height. So I'm going to take that first degree measurement again, that's being tripled, and again I'm going to cube it, so it will be 27 times larger. Okay? Because I'm talking about a third degree measurement increase. Okay, and that is it for the examples. I hope that this helped, and if you have any questions, please feel free to ask me the next time you see me in class. I hope you guys have a great day.